Okay, in this video I'm just going to go through some of the basic definitions for waves. Remember that a vibration is something that moves back and forth about an equilibrium position at one point in space. If that vibration is able to disturb some sort of medium, like imagine your hand slapping the top of the water repeatedly, then it's going to create a wave in that medium, and that wave will transfer your energy outwards to other things. So a wave, like a vibration, repeats in time, but it also repeats in position. That means if you were to draw a wave, and I'll just use the normal sinusoidal function to represent my wave, then for the disturbance in the medium, or the y-axis here, we could have a whole bunch of different things depending on the kind of wave we're dealing with. Like if it was a water wave, we might have height as it would be measured in meters. If it was a sound wave, we might have a measure of the air pressure, or pascals, or something like that. So it depends on the kind of wave. So we can't really label that axis unless we define what kind of a wave it is. But in general, what's interesting is that since it's both repeating in position and time, that x-axis could either be position or time. Now, if you want to imagine that, if you imagine yourself on a boat, then you can imagine in time the boat's going up and down and up and down. So if you close your eyes, you could feel that motion of the boat. Alternatively, if you want to see how the wave repeats in position, you could take a photograph, and if you took the photograph of the wave, you would see that the wave goes up and down and up and down. So it's both at a fixed time, varying in position, and in a fixed position, varying in time. Now let's just say that this graph was for time. If we take one cycle of the wave, the amount of time required for that one cycle is the period, and that'd be measured in seconds. Alternatively, if we look at the graph with position on the x-axis, so now we're looking at our photograph to figure out how big the wave is. If we look at one repeating cycle, it's called the wavelength. The amplitude shows the average distance from the equilibrium position. The equilibrium position is what the medium would be at if it was undisturbed. So the distance from the equilibrium position to the bottom or the top of the wave. So careful with amplitude. It doesn't go all the way from the top to the bottom. It goes from the top to half or from the bottom to half. Finally, maybe a new definition here is phase. Phase is used when comparing two waves to figure out how they're going to line up with each other. Here we're going to have two examples, or two sort of extreme possibilities for phase. Imagine this is our original wave, and I'm just going to draw them out twice so that I can show the two different possibilities. If I were to draw a wave that was in phase with the original wave, what that means is that when the original wave goes up, the other wave would go up, and when the original wave goes down, the other wave would go down, and back and forth like that. What happens in this situation is that the two waves tend to be disturbed in the same way, so the resulting wave is very large. Alternatively, if we consider an out-of-phase wave, what that means is that the two waves are sort of doing opposite things. When one wave goes up, the other wave goes down, and vice versa. When it goes down, it goes up, and back and forth like that. What this means is that the waves are always out of step with each other, or out of phase with each other, and the resulting wave, when they try to occupy the same point in space, will be small. So that's some definitions of waves, and I'm going to go on in the next video to talk about the speed of a wave.